Welcome back to our series of videos on polynomial division. In this episode, we're going to look at two really important theorems in mathematics that really helps us do significant things with polynomials. The first one is called the Remainder Theorem. And the Remainder Theorem says if we have a polynomial f of x and we divide our polynomial by x minus a, then the remainder is equal to our function evaluated at a. So by dividing, we're able to evaluate a polynomial. This might not seem that impressive initially, but there's a very clever way that we can prove this. So our proof says we have our function f of x divided by x minus a, and this is equal to some quotient, which may be a polynomial, plus a remainder, which I'm writing in function notation because it's part of a polynomial, divided by x minus a, which is what we're dividing by. Now let's multiply everything by x minus a. Well, on the left-hand side, it just cancels out, so we have f of x. On the right-hand side, we can multiply our first term. We have x minus a times our quotient, 2 of x. And then when we multiply r of x divided by x minus a by x minus a, the denominator cancels out, and we're just left with the remainder. And here's where the clever part comes in. If we plug in a for x, we have a minus a times the quotient evaluated at a plus the remainder evaluated at a. And then we see that a minus a is just 0. So this whole term, including the q, goes away, and f of a is then equal to our remainder. We might not be that impressed by this, and in the scheme of things, by now, with the technology we have, it seems kind of simple and dated. But this does allow us to prove something really important that we've already been using for years without being able to say why it works. And that is the factor theorem. And the factor theorem says that if we have, it essentially equates division through the use of the remainder theorem with evaluating and factoring. So if f of x has a factor x minus a, then f of a is equal to 0. But this goes a step further. It also says if f of a is equal to 0, then f of x has a factor x minus a. So it tells us two different things. First, if we can factor something, we know that those are the zeros of the function. This is what we've been doing for years when we factor quadratic equations using the x method or whatever other method you you've used, because it tells us these are the zeros of the function. Alternatively, if we don't know how to factor a function, if we can find a zero, usually through trial and error, then we know that that function can be factored. So written in a slightly different way, what our factor theorem says is that if we have f of x divided by a factor x minus a, it equals a quotient. But because we're assuming that this is a factor of the function, the remainder is 0. This is where the remainder theorem comes in. So then we can say f of x can be factored as x minus a times the quotient. And in practice, we're often going to factor the quotient until we can get to a linear factorization. That means all of our factors are linear. But for right now, this is really what the factor theorem says. It might not seem all that profound. It seems like this is something that's obvious. We've known this forever. But it's a really important thing in math to be able to prove what we know rather than just taking things on faith. We want to know that what we know is true. And by using polynomial division and our remainder theorem, we're able to prove the factor theorem and show that this seemingly obvious fact is actually true, and it's always true.